Today we're going to look at probability. First couple of questions aren't too bad. It says, what is the probability that you get a 2 on a single throw of a fair die? So you roll dice, numbered 1 through 6, and I ask you, what's the probability that you get a 2? Well, you have one chance out of 6, so the probability is 1/6. A card is drawn from a standard deck without replacement. What is the probability that the card is a king? Well, there are 52 cards in the deck, and there are 4 of them that are kings. So 4 out of 52, which I can reduce that fraction, it's 1/13. 3 cards are drawn from a standard deck of 52 without replacement. What is the probability that all 3 cards are kings? Well, the probability that the first is a king is 4 out of 52. Okay, now that card is sitting on my desk. Now I want to find the probability that the next card would be a king. Now I only have 3 chances out of 51 cards because the other one's on my desk. Now I put that one on my desk and I want to find the probability that the third one is a king. Well, I only have 2 chances out of 51. I do multiplication in between because it is, I want a king and a king and a king. Remember, and means multiply. So I multiply that through, and it will give me 0.000181. You might have something that looks like this in your calculator instead, 1.81 e negative 4. Remember that e negative 4 means you move that decimal to 4 places to the left. The next one, the letters of the word tomato are arranged at random. What's the probability that the arrangement begins and ends with a T? Well, first of all, I see I have 6 letters in that word tomato. So I'm just going to try to do it pictorially here. I want it to begin with the letter T. I see I have 2 options where it could begin with the letter T for that first spot. If I use that T in the first spot, I have to use the other T in the last spot because it has to begin and end with a T. Then you look and you see you have 4 letters left. So you have 4 options for the second spot, 3 options for the third, 2 options for the fourth, 1 option for the 5th spot. This will be multiplication in between. And that gives you 48. So there's 48 different ways that the letters of the word tomato can be arranged so it begins and ends with a T. Now, you want a probability. So it's going to be 48 divided by all of the total possibilities. The total possibilities are 6 factorial because you have 6 letters that you can arrange here. Now, I know you're thinking, well, don't I have to divide out the common O's or the common T's? The answer is no, because we don't care about different arrangements like the previous day. We just care about arrangements. So you take 48 divided by 6 factorial, and you get 1/15. Next one. 3 construction companies bid on a renovation project for a supermarket. So these 3 companies want to renovate the market. The owner of the Well-Belt company says that their competitors have a probability of 0.2 and 0.4 of getting the job. I want to know the probability that Well-Built will get the job. Well, if the one company has a 20% chance and the other company has a 40% chance, that's 60% altogether, 0.6. The probability that Well-Built gets the job is 100%, or 1 minus 0.6, which is 0.4. So the probability they get the job is 0.4. A die was rolled 1,200 times, and number 5 came up 429 times. Find the experimental probability of rolling a 5. Experimental probability is what happened in the experiment. So it came up 429 times out of 1,200. 429 out of 1,200 is 0.3575. The theoretical probability of rolling a 5 is 1 out of 6. You have a 1/6 of a chance. Which as a decimal is 0.1667. Do you think the die was fair? It would be fair if those probabilities were close together. Those probabilities are not close together. This is about 36% of the time, and this is only saying about 17% of the time. So it's not fair. No, because the probabilities are too different. Okay. Instant oatmeal container has 10 plain, 6 maple, 4 apple cinnamon. Ernestine reaches in and takes 3 packets without looking. Find the probability. Okay. First we want to find the probability of 2 plain. Well, out of all the plains, there's 10 of them, and she wants to choose 2 of them. So it's going to be 10, choose 2. She is picking another packet. So she has her 2 plains, order doesn't matter. And however, there are 10 other packets left, and she wants to pick one of them to be not the plain out of 20 packets altogether, choosing any 3. So the 10 choose 2 represents her picking a plain out of the 10 plain. The 10 choose 1 represents picking a not plain out of the maples and apple cinnamons. And the 20 choose 3 shows the total probabilities. So when we type this in our calculator, you're going to type 10 math arrow over to probability, choose 1, times 10 math arrow over to probability, choose the C1 again, 1, divided by 20, choose 3. And you end up getting 0.0877. That's about 9%. Probability of 1 maple and 1 apple cinnamon. Well, for the maple, I have 6 maple, and I want to choose 1 of them. For the apple cinnamon, I have 4 apple cinnamon, and I want to choose 1 of them. And then I don't want any more maples or apple cinnamon, so I have 10 plains, and I want to choose 1 of them to be, and then 20, choose 3. And you type that in your calculator, and you get 0.2105. So that's about 21%. I'm going to leave you guys with the last 2 to try.